here in a little bit.
That's fine.
I haven't got it posted myself yet. All right, so I
Right.
am recording. So we're gonna do things a little bit differently. We, of course, as adults, we have all kinds of weird schedules going right now, especially with the way things are. So we're gonna adjust things just a little bit. We're gonna still meet at 10 o'clock next week, every day. You will likely see for sure one of us. Sometimes it might just be one of us. We're gonna try to do both of us as much as we possibly can, because we know that that's probably more effective. But starting next week, we're not going to do Fridays. We're going to give you guys Fridays off. Doesn't that sound great?
Yay! Sounds awesome.
So we're going to just do Monday through Thursday. We're going to still do 10 o'clock in the morning. Okay. And for those of you watching, if I end up, if the baby touches something, I'm sorry, I will come back. I might just, if it disappears, if he somehow turns it off, because he really is very interested in touching that keyboard, aren't you? Yes. All right, Mr. Rondo, I'm going to let you say whatever you want to say. Okay.
No sweat. Yeah, just echoing that. No Fridays. We'll keep it at 10. Today I'm gonna scoot out. I actually almost missed the time because I have my own class that I'm working on and I'm not finished and I have to finish it up today. So Miss Ballard graciously said that she would take over class today, and then there's there'll be a time here or there where I will just do class for her. So we're just helping each other out. Thank you guys for your patience. And I'm going to head out and see you guys next week. I'll be with you again, 10 a.m. And Miss Ballard, if you can, before you leave though, do the count, because
I will try. I will try. If nothing else, I'll do it after I I'll take the picture of the roll and I'll do it at the end after I let everybody go. So.
Okay, because I still want to win, even if I can't be here.
I know you do. Ellie, what was that? Okay, go. All right.
Anyways, sorry. All right. Well,
we have a lot going on here today.
What's that?
We have a lot going on here today.
Well, and if need be, shoot me a text and I can jump back in if something goes crazy.
Good. But thank you. Well, we're gonna manage it. We're gonna get through it. So because it's a short, it's gonna be pretty short today. All right.
All right. Bye, guys.
Bye. Thank you. All right. So I'm gonna go ahead and get going, guys. And get you guys. We're gonna get through this as quickly as we can. I'm trying to look at my notes on the other page though, and there it is. Okay. So I'm gonna share my screen with you. Okay. We might not ask quite as many questions in the chat today, so I'm not going to be watching the chat when I turn this on. So if you guys have a question or you're not understanding something, please come off your microphone and yell at me, okay? And I apologize that Mickey Mouse and the Roadster Racers is in the background. Though it is awesome, I'm trying to entertain the children and watch them because my husband's in a meeting, my daughter's in a meeting, and I'm in a meeting. Oh, and so are you. Would you like to sit on my lap the right way now? Okay. You're gonna watch mommy right? Okay, you gotta watch mommy right, okay? Uh-oh, there goes that computer, and there goes my notes. Okay, we're gonna see what we can do here. I apologize, just give me 1 second. I gotta get back into this other machine where my notes are. Okay, we are good to go now. All right, so I'm going to go ahead and flip my screen, so you're going to probably see my ceiling or up one of our noses. Okay, hey. Oh, that was very good words there, Davey. Nice and clear. Okay, so we're going to be on this page that says, okay, Mikey, I need you to go watch the TV, okay? All right, we're going to be on the page that says build and use the unit circle, okay? And our essential question for the day is going to be, what is the relationship? We're going to try. No, I don't want you touching this. Okay. Don't touch, please. Davey, don't touch. He really wants to touch. What is the relationship? Sorry, it's hard to write with the baby on your lap. Ship between. Is Daddy off? Oh, there's Daddy. Oh, good. Daddy's here. Daddy's here. All right, Daddy. Thank you. Thank you. Okay. I'm going to rewrite that for you guys because it is. You got to go. You got to go with Daddy. He's going to go do fun things like go in the pool or something. Go. There you go. Okay. We're going to start this again. All right. be a little less babies, but I'm still not going to be able to see the chat. So you guys are going to have to let me know in the chat what's going on, okay? So what is the relationship between the angles and the 30, 60, 90 and 45, 45, 90 triangles and the angle measures of the unit circle? Okay, I'm going to let you take a minute and write that down. I'm going to go turn off Mickey and the Roadster Racers, okay? All right, here we go. We're going to cook with gas now. All right, so first of all, what on earth is this weird thing that we call the unit circle? Okay, I'm just going to flip back. You guys look like you're all still there. Awesome. Okay. So the unit circle is basically a circle that is unit 1. So when we draw a circle on here, it's mostly circular, we're going to say that our radius length is 1. So that's what it means by a unit circle. Okay. We can basically, what we're going to do is come up with a method to be able to figure out any coordinate on that circle from that 1 unit circle. Okay. So the way that that's going to happen is we're going to use these triangles, these right triangles. In the triangles, and mine's getting a little tiny, this is going to be the x leg. And it doesn't matter where I place this triangle in the circle. We're going to use the reference angles, the angle closest into the origin. And then we're going to use y as the height, because that's the y direction. And we're just going to use r for radius. I know I'm going to make it super tiny now. Let's see if I can get it in there. This would be, whoa. Let's see if I can zoom a little. This would be my opposite, this would be my adjacent, and this would be my hypotenuse. So and the orange is kind of our SOHCAHTOA values. All right, I'm going to write SOHCAHTOA over here to the side. All right, so just based on that, I'm going to look at, so I'm officially writing the mathematical terminology or the mathematical ratios for SOHCAHTOA of that unit circle. So the sine of that circle would be the opposite over the hypotenuse, which on our opposite is y, and on our hypotenuse is r. And then cosecant would just be the reciprocal of that, r over y. The cosine is the adjacent, which would be, it has an x on it, and the hypotenuse would be the r. And again, for secant, we learned earlier this week that we would just flip it. And then tangent would be the opposite, which is y, because we're looking at TOA. So y over the adjacent, which is x, and then cotangent is just going to be the reciprocal of it. I'm going to let you take a minute to write that down. Okay. We're going to kind of take a quick look at some trig identities. This first part's weird. I was going to skip it, but I don't want to because of what we're going to assign for Delta Math, just in case one of these comes up. We're going to look at the majority of the unit circle based on the triangles today from that perspective. Eventually, we're going to teach it to you another way. But so this first part's going to seem a little strange. When we can't use the triangles when we are on the quadrant angles, okay? So I'm going to teach you a quadrant angle method right now where you can use this chart to help you, and eventually it's going to make more sense in a lesson or two when we teach you one other layer of this, okay? But today we're trying to make the connection between the triangles and the unit circle, okay? So the relationship between cosecant and sine, we've already learned is they're reciprocals, and I'm being really lazy and not writing a variable after that. So we know cosecant is 1 over sine. We know that secant is 1 over cosine. We know that tangent is sine over cosine. And cotangent would be the reciprocal of that, cosine over sine. And I know that kind of seems weird, but it's just like any formula I would give you. It's something that we know is a true thing. I'm not going to try to prove it today, but it's something we know that is true. All right, so somewhere you should have this table and this little chart, this little graph, okay? In this graph, I'm going to tell you that these are the coordinates, and we'll end up proving this a little bit better in a couple of days, okay? Maybe Monday or Tuesday. But today you're just going to take my word for it. The cosine is always going to be our x coordinate, and the sine is always going to be our y coordinate. So we know that this angle here is 0, or it could be, or 2 pi and 360. 360, 2 pi, okay? I know that up here is 90, or pi over 2. I know that here is 180, or just pi, depending upon if I'm doing degrees or radians. And then this at the bottom is 270, or 3 pi over 2. And we went over that the last couple of days. So I am going to look at, so if I'm asking you to find, say, we're going to fill out this chart. Say I'm going to ask you to find the sine of 90. I would go to 90, and all I'm going to do is I'm going to read the y coordinate. So the sine of 90 is equal to 1. If you were to put the sine of 90 into your calculator, it would equal 1. Okay, I'm going to keep going with sine. So sine of 180 would be this y coordinate, which is 0. Sine of 270 would be this y coordinate, which is -1. Sine of 360 is this y coordinate, which is 0. All right, now let's do cosine. It tells us cosine is the x coordinate. So I'm going to go to the cosine of 90, which would be 0. The cosine of 180 is -1. The cosine of 270 is 0. And the cosine of 360, 2 pi, or we could add 0 in there because it's all going to be the same because they're coterminal, is 1. Okay. Now that we have those two, the rest of them all are based on those two. To do the tangent, we just set up here, tangent is my sine divided by my cosine. So I'm going to take my sine, which is 1, and I'm going to divide it by my cosine, which is 0, but we have a problem. We are not allowed to divide by 0. So instead of writing that, we would write that it is, and I'm sorry I didn't leave enough space, undefined. You can use undefined if you want. Undefined, UN. I think I just use UND. Okay. All right, let's try the next one here. So the next one, that's the sine divided by the cosine, be 0 divided by -1, which ends up being just 0. So the tangent of 180 is 0. The tangent of 270, I'm going to take -1, and I'm going to divide it by 0. And again, this is going to turn out to be undefined. Okay. And then I'm going to, for 360, I'm going to take 0, and I'm going to divide it by 1, which is going to be equal to 0. All right, I'm going to go back to these relationships up at the top here, and I'm going to look at the relationship for cosecant. Well, cosecant says that it's 1 over sine. So all of these here, I'm going to start with a 1 on the top, and I'm going to put these values on the bottom. So this first one is 1 over 1, which is just going to be 1. This one's going to be 1 over 0. Uh-oh, we know that that one is undefined. That's how I abbreviate undefined. That looks a little bit better. UNDEF. All right, and then this one's going to be 1 divided by -1, which ends up being -1. This one will be 1 over 0, which again is undefined. On tangent, cosecant, secant, and cotangent, you're going to have things that are undefined, okay? It has to do with asymptotes, which I know we didn't really talk about this year. We will get to that, and I'll show you what they are eventually when we get to that point. But that's what, there's something missing in that function on the graph when we get to the graphing point. All right, secant is 1 over, so I need a 1 over, so it's 1 over cosine. So I'm going to put 1 on the top of all of them. And then I'm going to go back to my cosine row. So 1 over cosine, that one was green. All right, so it's going to be 0, -1, 0, and 1 if I just copy that row. So let's figure out what's undefined and reduce. So 1 over 0 is undefined. 1 over -1 is -1. 1 over 0 again is undefined, and 1 over 1 is 1. All right, and then finally cotangent. Cotangent is, I have two ways I could do it. I could do it as cosine over sine, or I could do it as 1 over tangent, but we're going to mostly have the sine and the cosine, so let's go with it that way. So I know that this one's going to be 0 divided by 1, which is just going to be 0. Then I've got -1 divided by 0, which, undefined. We don't want to divide by 0. Our papers might explode. All right, and then I've got 0 divided by -1, which is 0. And then we've got 1 divided by 0, which is undefined. So the whole purpose of doing that is when you see with the problems, if you hit a problem that says find the tangent of pi or the tangent of 180, I know that I would come to my chart and I would go, oh, I know that the tangent of 180 equals 0, okay? Or I could go to my coordinates up here and I could go to the tangent of 180 and I'm going to go, oh, I know that this is cosine and this is sine. So I would take sine divided by cosine. It would be 0 over -1 or 0. We will get more into the coordinates later, okay, in the lesson or two. Right now we're going to just stick with, if you see one of those, let's use the chart, okay? Not the best way, most effective way to do it, but it's going to work for today, okay? All right. Hopefully you have this circle in front of you. I can't see all of mine there. Let me see if I can, oh wait, if I zoom out, there we go. Okay, now I can see everything. So all we're going to do, I'm going to teach you how I use the circle. Normally we spend a couple of days in class building this. We will do it, where I'm not going to leave that out. It's like one of those traditional points of your education that, like, it's a rite of passage kind of thing. So we're going to do it, okay? We'll do it like in the first day or two. We're back in the fall, I promise, okay? So so that way you have it, because I'm sure you've seen other kids carrying theirs. My calculus students usually still have theirs from year to year. So, because it's a really useful tool. So I'm going to teach you how we kind of start using this unit circle. So you'll notice this outer ring, this orange ring. It's got some words in it. And the words in it are all, and then I use a mnemonic device. All students take calculus. It's my subliminal message that you need to take calculus. But the S stands for sine. So sine and its reciprocal in quadrant 2 are positive. In this one here, in quadrant 1, every single one of them is positive. In quadrant 3, the T stands for the T in take stands for tangent, meaning tangent and cotangent are positive. And in quadrant 4, the C in calculus stands for cosine. So that means that cosine is positive in that quadrant. So really let me just go through that and then I'll explain the triangles. Okay, so all we're going to do is look and see what is positive and what is negative in each quadrant, okay? And we're going to have to work with our coterminals a little bit. So first of all, I need the tangent of -3 or 135. So either we can count where that's going to be, or I could just add 360 doing coterminal like we did yesterday. So that's what I'm going to do. And I get the sine of 225 degrees is coterminal to it. So I'm going to find 225. And I know we were doing sine. The only thing that's positive here is tangent and cotangent, meaning that sine, cosecant, cosine, and secant are all negative. So I know that I'm not writing the equivalency. All I know, I just need to know that it's negative. I can either write the little symbol or I can write out the word negative. All right, cosine of 405. Well, I know that that's not on my unit circle because my unit circle only goes up to 360. So I'm going to subtract 360 doing the coterminals that we did yesterday. And that's going to give me that it's coterminal to the cosine of 45. Well, 45 is here. And I know the signs of all of them are positive there. So I know that this is positive. Okay. All right, then the tangent to 315, I'm going to look for 315, and what do you know? 315 is there. The only thing I'm allowed to have positive in quadrant 4 is cosine and secant. So I know that when I have tangent, it has to be negative because it's not either cosine or secant. All right. Ooh, the cotangent of 2 pi. And you'll notice 2 pi is one of our quadrant angles. So when we do a quadrant angle, that's when I have to come back up here, and I'm looking for the 2 pi, quadrant angle of 2 pi, and I notice that it is undefined. So I'm just going to write that it is undefined. Okay. All right. I'm going to look at the cosecant of pi over 4. Normally, I would pause and have you guys do this part, but I'm just going to go ahead and go through it since we are in this strange situation and we're one short today. Okay. So cosecant of pi over 4. So pi over 4 is here. We know everything in quadrant 1 is positive. And then the secant of 11 pi over 4. Well, I noticed that I got 7 pi over 4, but I don't have 11 pi over 4. So you can either count your wedges, okay, like Miss Rondeau did. I could do that. 1, 2, up to there. 3, I'm doing the over 4 wedges. 5, 6, 7, 8, 9, 10, 11. Looks like it would land there. So I could do that. No, I could not. I miscounted somewhere. I should be one more wedge. I should be right here. I'd land there, okay? Or I could subtract 2 pi. And remember how yesterday we talked about the equivalency of 2 pi, and over 4 world, we would really be subtracting 8 pi over 4. So 11 pi minus 8 pi is 3 pi over 4. So I know I'm here, and I'm looking for the secant, just the sign of the secant. Only sine and cosecant are allowed to be positive, so I know that secant has to be negative. All right, I'm going to kind of erase my scribbles. And I'm going to look for the tangent of 90. Well, I know 90 is on a quadrant angle, meaning it's on the x-axis or the y-axis. So I'm going to come back up to the table and I'm looking for the sine. It says in the table that the sine is undefined. Okay. All right, and then finally we have the cotangent of negative 45 degrees. So I could add 360, and when I add 360, I end up with 315. Or I can use the count the wedges method, okay? And I could come backwards one wedge because I know that when I'm negative, I have to go down first instead of up on the unit circle. So, and both of them bring us to 315, okay? So so if I'm looking for cotangent, I notice cotangent is not one of these values. So the cotangent is negative. So I know that this has to be negative. So that's kind of step 1. And I'm going to give you a couple of different methods on the next one. I'm going to teach you my way and Miss Rondeau's way. Okay. So I want you to notice that in the triangle here, okay, or in the unit circle, we have these things, these triangles are color coded. Okay. So I use this color coded method. So if I know I'm landing on a pink line, then I'm going to use the pink triangle. Well, and hopefully you notice that all the pink lines, look at the denominators are on all the pink lines. They're all over 4. Okay. And I should not have had a pink line there in the middle. I'm sorry. I guess I kind of do land there, but the coordinates up at the top kind of trump that. All right, and then hopefully you'll notice that there's the green triangle and the green lines. Look at all their denominators. They're all over 3. Okay. So anytime you land on a green line, you're going to use the green triangle. If I actually had that, normally you would see that angle measure there actually matches this angle measure here. It's actually a 60-degree reference angle, okay? And then finally, if you look at the blue ones, they're all over 6 for their denominators. So they're going to use this blue reference triangle, okay? So I refer back to the triangles. The other thing we can do is we can always draw our unit circle. We can always draw the triangle. So say I did not draw a blue triangle there. All right, so I could draw my triangle and always decide, hey, that's the 1, this is the 2, this is the square root of 3. Sometimes our triangle is upside down. Look, I could draw an upside down triangle in there, okay? So I am down, and really for that, I would be down 1. I am to the left, square root of 3, and I would be hypotenuse too. So I'm going to kind of show you both methods, all right? I'm going to show you the triangle method first on the first couple of examples, and then I will I'll try the color coding triangle method first, and then I will show you the drawing the triangle method second. So that way you get a little bit of both, okay? And you can decide which way you like it better, all right? So it doesn't matter. We will not be offended one way or the other if you like it one way, Miss Rondeau's way or Miss Ballard's way, okay? We just want you to learn it and learn it the way you understand it the best. So hopefully you figured out when we were doing these examples up here, it does not matter if you're in degrees or radians. This is going to work the exact same way, okay? So sometimes we're going to give you degrees, sometimes we're going to give you radians, and you do the exact same method either way, or you can do the exact same process either way, okay? So let me erase what I had there. All right, so I'm going to find the cosine of 150. Okay, so I'm going to look for that on there. I can, if I need to, do the coterminal thing if I have to, just like we were doing in the earlier examples. So I'm seeing the cosine of 150 right there. I notice that it is blue, so I am going to use the blue triangle. Okay, the first thing I do is I look out here and I say, oh, guess what? The sine, I know in quadrant 2, the sine for sine and cosecant is positive, everything else is negative. So my cosine has to be negative. Then I know my reference triangle is the blue triangle, and for cosine, I know I'm working with Ka from SOHCAHTOA. I'm going to do the adjacent over the hypotenuse. So I'm going to write square root of 3 over 2. And I hope you noticed in the instructions this weird word, exact value. We don't want you putting these in the calculator. The answers on Delta Math's assignment won't be in the calculator. It's going to be, this is what they call the exact value, a radical over a number, or you might have to rationalize that, okay? All right, I'm going to erase my thing again, okay? All right, let's look at the next one. So it says 135. So I'm going to find 135 on my unit circle, okay? I notice it's the pink triangle, so I'm going to use my pink triangle this time. And the cosecant in this quadrant, I notice is positive. I know you don't have to write a plus sign in front of anything, but I do that so I kind of check that off in my brain. Hey, I know it was a plus sign, so I know that I've actually checked to see if it's positive or negative. All right, then I know that cosecant, so now I'm thinking unit circle, SOHCAHTOA. Unit circle is the bottom part of the saying. It's cho, okay, because it's cosecant is the reciprocal of sine. So I know I need the hypotenuse over the opposite. So I'm going to do square root of 2 over 1. It's okay for us if you leave the 1. Delta Math or WebAssign might not take it, so you might just have to write square root of 2, and they probably won't take the plus sign in front. For our purposes, we don't care either way, but for getting it into a computer, you might have to do a little bit more simplification, okay? All right, let's try this again. All right, so we've got the sine of 240, so let's find 240. 240 is right here, okay? And notice it's green reference triangle, so I'm going to use the green triangle this time, okay? In this quadrant, I look out in the orange ring first. I notice that tangent and cotangent are positive, but sine is negative, so I get to put a negative sign. And then sine is so I am doing the opposite of the 60-degree reference angle, and I'm doing the hypotenuse. So I've got square root of 3 over 2, and that's it. That's the exact value. Hopefully you've noticed that there's not a lot of written work over here, but there's a whole lot of thinking going on with the unit circle. So it's not, there's a lot of processes you're doing as we're going through this. Okay, I'm going to do one more with the triangles here, okay, and with the color-coded triangle method, okay, and then we will switch to showing you how to use the triangles in there, okay. We'll switch to drawing triangles. All right, so I am going to go to tangent of 5 pi over 6. So 5 pi over 6 is here, okay? I know that my tangent, oh, let's see, it's a blue line, so I'm going to go with my blue reference triangle. I know tangent cannot be positive in that quadrant, so I'm going to write a negative sign in front. And then tangent is TOA, so I need my opposite, which is 1, and my adjacent, which is square root of 3. So I get 1 over square root of 3. But we don't like that radical in the denominator, so we do need to rationalize it. So it'd be negative square root of 3 over 3, because a radical times itself is just the number underneath, and that should be an equal sign, not a multiply. All right. Next, we're going to do the triangle method. Okay. So we're going to I'm still going to use my picture here, and hopefully you grabbed that picture. I emailed it out earlier today, so hopefully you've got it. I forgot to mention that. Okay. So I'm going to draw my triangle. So it says that we're doing the cotangent of 5 pi over 4. So I do need to know where that is. So you could count that out on your unit circle, just like we taught you the other day. You could use this picture and go, oh yeah, 5 pi over 4 is right here. I'm going to draw that triangle. So I'm going to do, in the interest of time, I'm going to just draw it on there. Okay. And then I know that that is my over 4 refers to my pink triangle. So I'm going to use that triangle a little bit as reference. So I know that my reference angle is 45 degrees. So I could draw my little, this is what Miss Rondeau did. She would draw this on there, and then she would draw her her leg lengths on there. So I know that this is out -1. I know it is down -1, and I know that it is square root of 2 on that leg. So I am looking for cotangent according to our problem. So cotangent is, it's TOA on the top, but cotangent is, that's not right. Yes, it is. So TOA, CHO, cow. Oh, not T. Where did the T come from? I drew it with the tangent. I'm like, that doesn't look right. I don't remember cat being part of the acronym. Cow. So we're looking for that. Okay. So I need my adjacent leg, which this is the reference angle. It's always coming out of the origin. So this is my adjacent. This is my opposite. So I would write that this is -1 over -1, which reduces to +1. Again, this is another way to do the exact same thing. So you can choose which way you like better. All right, I'm going to go ahead and erase, and I'm going to do it again. Okay, so I'm going to do Miss Rondeau's method again. All right, so 8 pi over 3. I'm looking at my answers here. That one isn't on our unit circle, so I need to get to 8 pi over 3. So I am going to either I count it out, or I'm going to subtract 2 pi, which in over 3 world we learned yesterday 2 pi is 6 pi over 3. So this is really the same as the secant of 2 pi over 3. All right, so the secant of 2 pi over 3 would be a green reference triangle, which means that I would draw my triangle in there, and my reference angle is 60 degrees. I'm going to draw it down here so you can see it a little bit better, because I'm kind of squished in there. Okay. Meaning across from my 60, my opposite is always square root of 3. My hypotenuse is always 2. And in this case, because I went in the negative direction, that's going to be a -1 on it. All right, so secant is SHA. So my hypotenuse is 2, and my adjacent is -1. So that's what I'm going to write down. So I would have 2 over -1 equals -2. All right. I am going to do this again. I'm sorry, I kind of keep scrolling here, but I want you to be able to see. So 315. Well, let's see. Good news, it's on my unit circle. It's the pink triangle, so that means it's going to be my 45-degree reference. Okay. but I'm going to try to draw that for you. So I know it's this angle right here. I did not draw it looking 45, but we're going to mark it 45. I know my length of that triangle is 1. I know my height is going to be down -1, and I know my hypotenuse is going to be square root of 2. All right, and they were saying cotangent, so I know cotangent is cow. So I need the adjacent. So my adjacent is 1, and my opposite is -1. So I would have that this ratio is 1 over -1, which is -1. Okay, we got 2 more here, and then we get to get out early today. Isn't that awesome? All right, we've got 2 pi over 3. So 2 pi over 3 is right here. So then my triangle looks like that. It looks like the green triangle, so it's 60 degrees. Okay, and then I know across from the 60 is always square root of 3. I know across or next to the 60 is always 1, and across from the hypotenuse is always going to be the 2. So I'm going to use that triangle here. Secant is SHA, which means I need the hypotenuse and the adjacent. So my hypotenuse is 2, and my adjacent is 1, so I could just write 2. All right, I'm going to do this one more way this way. Okay, and then again, homework, you get to pick whatever is your favorite. All we care is that you're able to do this, and you're able to do it without anybody's help, or Photomath's help, or anything else that you can use to get the answer without doing it using your own brain. So we've got, notice it's the blue one, so I'm going to use this blue triangle here. I'm going to redraw. So it's going to look like this. And 30 would be my reference angle. I know opposite of 30 is 1. I know hypotenuse is 2, and I know adjacent is square root of 3. Okay. And hopefully you've recognized that the blue triangle and the green triangle are the same triangle, it's just where the reference angle is depends on what goes across from it. So we needed cosine, so that is ka part of SOHCAHTOA. So I need the adjacent, which is square root of 3, and the hypotenuse, which is 2. So I'm going to have square root of 3 over 2. And I believe that brings us to the end of where we are for the lesson today. Okay. So let me go to back over here. Don't go anywhere yet, though, because I haven't taken roll. I'm going to, we got 24 people today. Awesome. So there's, well, 23 because I am in there. So I'm going to take a picture so I can do a total count on which class got more of us here today. I'm seeing a lot of names that I recognize. So I kind of think it's my class, but we'll see. Okay. So some reminders. I haven't put it out there yet for mine. I know Ms. Rondeau doesn't have it out there yet. We will put out an assignment that goes with this. Okay. We will also put out we'll also put this video up. Okay, we'll put up yesterday's video if you missed it. And then we will put the, what else? We will, next week we're only going to go Monday through Thursday. Okay, and there will be one day where Miss Rondeau has to come in because I'm like triple booked one day. So, but after that, for the most part, we should both be there. We're going to stay consistent at 10 o'clock Monday through Thursday. Okay. Quick question. I think we need to give you guys credit. We've been taking roll every day. I've at least been taking the picture of the list. So get the word out there that we'll give you some credit. Maybe we'll throw some points in there. I haven't talked about that with Ms. Rondeau, but I say we should give you guys points. What do you guys think? Do you think we should give you guys some points for showing up here every day? Ashley says yes. Does anybody else think that's a good idea? Okay. I think we should get some points for that. So I will figure out, I will convince Ms. Rondeau that we need to do that. Okay. Does that sound good? All right. So I'm going to go ahead. I'm going to hit this button here before I totally let you guys go.